Parallel lines. Two distinct, that just means it's not the same line written two different ways. So two distinct or different non-vertical lines are parallel if they have the same slope. Remembering that simple fact will help you all the way through AP Calculus. So when you hear the word parallel, you need to immediately think same slope. When you hear the word parallel, you need to immediately think the same slope. And it turns out that all vertical lines are parallel as well. And the reason they set that apart is because since vertical lines have an undefined slope, we can't really say undefined equals undefined, but all vertical lines are parallel. So let's talk through what they'll normally have us do. Write an equation in slope-intercept form for the line that passes through -1, 6 and is parallel to the graph of y equals 2x plus 12. So as soon as I see the word parallel, I think same slope. So to accomplish this goal, we'll determine the slope of the line that is given. Since the two lines are parallel, this is also the slope of the line we're trying to find. If it seems I'm sounding repetitive, it's on purpose. Got to remember parallel means same slope. Since they gave us this equation in slope-intercept form, I know the slope is right here. So since the slope of this line is 2, the slope of the new line that's passing through this point is also 2. So we'll then plug the slope and the given point, so this information right here, into the point slope form because we have a point and we have a slope. So let's go ahead and do that. So I'll do y minus 6 because that's the y value equals the slope times x minus -1, which is plus 1. So that's our point slope form. But they did ask for it in slope-intercept form. So our final step is to rewrite the equation into slope-intercept form. And that takes just 2 steps. There's always just 2 steps to take when you're transitioning from point slope to slope-intercept. That's to distribute the slope and then move the constant that's over here at the y over to the other side. In this case, it's adding. Sometimes it might be subtracting, but either adding or subtracting to move that term over. So our final answer is y equals 2x plus 8. So that line is parallel to this one because they have the same slope, but it passes through this point, which makes it different from this line. Okay, so the next 4, very similar. Number 1, our instructions are the same. Write an equation in slope-intercept form that passes through the given point and is parallel, meaning same slope, to the graph of each equation. So this has a slope of 1. So we have a slope of 1 and a 0.51. So we'll start by writing it in point slope form. And this 1 is coming from the y value of the point. Then this 1 is the slope. We do x minus 5 because 5 is the x value. So we distribute the 1, which really changes nothing, just gets rid of our parentheses. Then we add 1 to both sides. So we get y equals x minus 4. So that line is parallel to this line, but it goes through a point that this line does not. Okay, I'm going to jump down to number 3. I will do 2 and 4, but number 3 is a little bit different because this did not give us the slope in y-intercept. This did not give us the equation in slope-intercept form. So it turns out there's 2 ways you can find the slope when things are in standard form. One is, of course, to just rewrite this in slope-intercept form. I could subtract the 4x over, then divide everything by negative 3. That's completely fine. But it turns out there is a shortcut I can teach you, but this shortcut only works when you're in standard form. So don't try to use this in other times. But it turns out that when you're in standard form, the slope can be found by doing negative a over b. Meaning, you put a negative or just change the sign of the coefficient in front of x, that's a, and divide by the coefficient in front of b. So for this one, a is 4, so I make it a negative 4, and b is negative 3. So the slope of this line is 4/3. And you get the same thing if you just solve for y and put it in slope-intercept form. And you can do it either way. So now we have a point, we have a slope. So let's write the equation in point-slope form. Y minus 3, that's the y value, equals the slope times x plus 3, because the x value is negative 3, so minus the negative 3, same as plus 3. So we will distribute the slope. 4/3 times x is 4/3 x. 4/3 times 3, the 3's cancel out, so it's just 4. Or you can think of it this way. 4 times 3 is 12. 12 divided by 3 is 4. Then our last step is to add 3 to both sides. And we get y equals 4/3 x plus 7. Now what I would encourage you to do is pause the video and try and see if you can do number 2 and number 4 on your own. So I'll be quiet for just a moment to give you time to pause, then I'll show number 1, 2, and 4. Okay, our slope is the same as this one's, which is negative 1/2. So we would do y minus 7 equals negative 1/2 times x plus 8. We distribute the negative 1/2. Negative 1/2 times 8 is negative 4. Then we add 7 to both sides. And, ironically, we ended up with the same line. This won't happen often, but it may happen sometimes. It happened because this line passes through negative 8, 7. So if I make a parallel line that goes through that point, it's going to be the same as the line we started with. But you did not have to foresee that. It's fine that we just find that out in the answer. It'll be pretty uncommon that that happens. Okay, on number 4, they gave it to us in standard form. So remember, we can use the trick where we do negative a over b. So we do negative 3, because it's positive 3, but we change the sign, over 1, because the understood coefficient in front of y is 1. So our slope is negative 3, and we're using the point negative 1/6. So I'll do y minus 6 equals negative 3 times x plus 1, because minus the negative 1 is the same as plus 1. We'll distribute the negative 3 and add 6 to both sides. This one says, find an equation of the line that has a y-intercept of negative 1 that is parallel to the graph of the line x minus 3y equals 6. So there's two ways you can use this information right here. A y-intercept is where it hits the y-axis, so it does tell you the ordered pair 0, negative 1 is part of the line. So you can just use that as a point, or if you remember, when we have y equals mx plus b, the slope-intercept form, the b is the y-intercept. So that actually will make this very quick, because once we find the slope of this line, we can just plug in the slope, plug negative 1 in for b, and we're done. So this is in standard form, so we can find the slope by doing negative a over b. The a is 1, so we do negative 1 over negative 3, which makes it 1/3. So our slope is 1/3, so we do y equals 1/3 x. And since they told us the y-intercept, we can just plug that in directly and have our line. Our last one is similar. It says find an equation of the line that has the y-intercept of -4, so b equals -4, and it's parallel to the graph of the line y equals 6. So remember, y equals 6, y equals a number, that is a horizontal line, which means the slope is 0. So that's just going to be y equals a number, but ours doesn't pass through 6. Ours passes through -4, because remember this is also the point 0, -4, so the y value is -4. Now, if you want, you can work this out using like the point and slope form. You could say y plus 4, because that right there, equals the slope times x minus 0. Because I got the 0 for the slope from the fact we're parallel to a horizontal line, 0 for the x from this ordered pair, and 0 times anything is 0. And then we subtract 4 from both sides, and we get y equals -4.